Professor Bob Winston and some of our work have done together. That is the dynamic and thermal mechanisms of urban impacts on rainfall in Beijing. Okay, okay. As one of Bob's students and maybe the only student speaker in this session, I have a word. In my eyes, Bob is very devoted into urban boundary layer. And to be honest, Bob is a vigorous professor, and we have thousands of thousands of revisions for every paper before it's submitted. And yeah, but that really helps a lot. Also, Bob is very humorous and knowledgeable and generosity. In one word, Bob is a scholarly mentor and a beneficial friend. Okay, we have known some of Bob's great contributions in previous presentations, and one of Bob's another contribution is that he hypothesized two ideal extreme cases of urban thermodynamic impacts on sandstone precipitation. You will learn that if urban has different impacts on precipitation under different conditions. And this is true for a 5-year climatology study based on summer precipitation in Beijing. That is, in under strong urban heat island, the precipitation mainly located over the urban area, and under weak urban heat island, the precipitation mainly located upward of the urban area and on lateral side of the urban area. We call this bifurcation. Well, this is a urban bifurcating thunderstorm observed during storm in Beijing. Before the thunderstorm arrived, the Beijing embraced big urban heat island, the urban heat island big. Under this condition, the radar echoes intensified over, over the lateral side of the urban area and weakened over the urban side of the over the urban area. So the total precipitation of this case show bifurcation around the urban area. And this visual distribution is consistent with our climatology analysis shown in the last slide. And to review the dynamic and thermal impacts of urban underlying surface, six simulations were conducted. In the control case, we used BEP urban scale. And in the following five sensitivity cases, the BEP plus BM scheme was used. Also, in the three cases, the sensible heat released from air conditioner was modified to a 10% of the 10% to 50% and to 200% to change the urban heat island intensity. Uh, First of all, the control case, that is the BEP case, show a consistent pattern of the precipitation with observations. The simulated precipitation also bifurcated around the urban area, and with the change of the sensible heat released from the air conditioner, the total surface sensible heat changed accordingly from 48 W per meter square to 287 W square meter, and the urban heat island increased accordingly from the 0.7 Celsius degree to 2.4 Celsius degree. With the increase of the urban heat island, the wind direction changed also. The surface flow, this is the 10-meter high surface flow. The surface flow began to converge into the urban area when the urban heat island was strong enough. This is the vector is the 10-meter height of wind at 1930 local sector, and the shade, the colors of the radar echoes 30 minutes later. This is during the thunderstorm past Beijing, past the urban area. We can see that in the big urban heat island cases, the convergence lab broke into two parts on lateral side of the urban area, and the radar echoes 30 minutes later, mainly located on lateral side of the urban area, impacted by the convergence pattern. The thunderstorm bifurcated, and in the strong urban heat island cases, the convergence line moved faster, and the radar echoes intensified over the urban area. As the result, no, this is not the result. This is the cross section, the vertical cross section along this red line. And the cross section also show that in the big urban heat island cases, the downward motion located over the urban area, and in the strong urban heat island cases, it is upward motion over the area. The upward motion moves into urban area and gets stronger with the increase of the urban heat island intensity. This is the precipitation result. These are the total precipitations from all the cases, and this is from observation, all simulated precipitation, and this is observation. We can see that in the big urban heat island cases, the precipitation bifurcated, and with the increase of the urban heat island, the bifurcation distance decrease with the urban heat island, and the urban total precipitation increase with the urban heat island. The correlation coefficient between the total precipitation and urban heat island intensity was 0.97. Okay, this is the summary. A bifurcating summer sandstorm over Beijing was analyzed by a series of wolf simulations. Bifurcation only under big urban island conditions with diver with big urban islands just like observation and the diverging flow around the urban area and the downward motion over the urban area. With the enhancement of urban heat island, the flow converged into urban area, bifurcation distance decreased, and the precipitation moved into urban area and then enhanced. Okay, we didn't mention the cooling tower scheme, but in fact we used the cooling tower in one of our cases. We found that the cooling tower scheme coupled into the BEM scheme can improve the simulated precipitation. This is the recommendation for the future efforts. A lot of work needed to be done in the future. For example, uh, yeah, the use of ensemble models, the more meteorology studies, both simulation and observation, the effect of smaller spring space, and the realistic building and more parametric simulation about the building that is the urban dynamic impact. That's all. That's my presentation. Thanks for Bob and thanks for you, Patrick and Eugene. Thank you all.
Presentation. So yeah, comments, students, David. Yeah, very good. You said I still like your applause a lot. I wanted to say that we are looking at the case of Houston now, with fresh eyes with the tracer experiment. The first case is the poster in session is precisely a week UHI event, and it's almost a mirror of what you look into the bifurcated event. So it's consistent to your findings, what we're seeing in Houston now. We have still more to learn, but we're going to look into more synoptic events, so we'll see whether the strong heat island really brings the precipitation in that case. The other factor that is, like I say, is a series from coupling to the case, but very consistent, so adds to the theory that Bob and you have enhanced over the years. So I'm going to have my student to be talking to you soon in this case.
Okay, okay.
Yeah, Jim Carlos is his name. Bob, any questions, any comments on those great presentation?
No, I have a revision to slide 12.
All right. No, you heard Bob, all right? Some revisions like 12 there. Okay, very good. All right. So, Eric, please